Welcome everyone to the afternoon session on Thursday, day 4 of the AGIC Symposium. This afternoon we have two great presentations for you today on outreach and collaboration. First up, I want to give you a little bit of reminders. If you have questions for either of our presenters, any of these presentations, please use the Q&A and we will be monitoring those, and as time permits, we will have the presenters respond to the questions live. Or if there's no time, we'll try to get those responded to you within the chat, type those in for you. The chat is open also as well during the course of the session. Feel free to comment and chat amongst yourself there, but be aware that we may not catch questions if they're not put into the Q&A. So use the Q&A instead of the chat. So first up, what we have, I'm going to stop my share here. I'm going to let Robert Bush get started sharing while I introduce him. So first up, we have Robert Bush and Reid Geiger. Hopefully I pronounced your last name correctly, Reid. They're going to be talking about where's the data, interagency outreach. And for those of you that don't know Robert Bush is a geospatial analyst at the Arizona Department of Transportation, or ADOT. He's been with ADOT for over 23 years. I had the privilege to work with Robert when I was there myself. Anyways, 15 of those years have been traveling all over Arizona, collecting roadway imagery along the state highway system. In 2017 came and he became a geospatial analyst, and we're thrilled to have him share some of his work today. And Reid, who's going to be presenting with him, is a GIS analyst for Works Consulting. And he is a young professional, enthusiastic about all things spatial. He completed his undergraduate degree in geography, concentrating on remote sensing and GIS from Indiana University. So we're excited to have them both, and I'm going to not waste any more of their time and turn it over to you, Robert.
Well, thank you, Jamie. I appreciate it. I'll let Reid start off with us and do the introductions, and then I'll move back to me. We've got a couple presentations to give you today. Go ahead, Reid.
Thank you very much, Robert. Hello, everyone. Today, Robert and I are going to be presenting on our journey of the past couple years doing interagency outreach, reaching out to other groups within our agency, trying to expand the power of GIS within ADOT. Robert, to you.
Yeah, our problem statement is data. As with most government agencies, probably, there is old school ADOT, old school DES, old school land department, whatever it is. There's data that's been around for years and years and years. It's tabular, it's spreadsheet, it's access databases, but it doesn't play well with others. And our first step was getting our foot in the door. How do we get these people to listen to us, to let them see what GIS can do for it? What's really scary about the whole thing is that we as GIS analysts know what we're capable of doing, but getting the other people, the subject matter experts, the data owners and everything like that, to open the doors and share with us their procedures and their data can be very difficult. Go ahead and go to the next screen, Reid. I hope everybody has heard the term towers of excellence. These are these decentralized databases that have tremendous amounts of data in them. They can range from just general information to down to everything you would want to know about a particular item, a sign on the road, a project, whatever it is. They're excellent sources of information. But as I said, they don't play together. In fact, lots of times people don't even know they exist. So the same data is collected over and over and over again in spreadsheets and databases and tabular form multiple times. That's what we are trying to work with at ADOT, is take down these towers of excellence, to bring them together into a GIS format. So now we have one center of truth for everything, and everybody can go to one location to get the same information that I'm going to get, that my coworker is going to get, or somebody from another division is going to get. They're going to look at the same data and hopefully come to the same conclusion. Go ahead, Reid. Our first example, I'm going to turn over to Reid. This is something that I started out working with, it's the Adopt a Highway program. And the old way that it was set up was very labor intensive on the GIS analyst. We had to exchange emails. We had to update maps manually. We had to create vertices and trace lines along the road and do a lot of work. And we weren't even the subject matter experts, nor was it our department that was working on it. So I was approached about doing something, and I came to Reid, and I'll let him tell you what he came up with. Go ahead.
Thank you, Robert. Yeah, so Robert approached me about making upgrades to this Adopt a Highway permit database. And so our goal here was to not only improve the database, but to also empower the end users and the subject matter experts in how to do this work themselves, so it could remove us from the process.
You got it, Reid.
Reid, I think you muted yourself.
I'm very sorry. Sorry about that, everyone. So I take it that no one heard this whole slide. So we first start off with the kickoff meeting, and this is a big thing here, that we discuss the needs and the possible solutions. And even sometimes in this first step, we won't even go about discussing possible solutions. We'll just listen to the group's needs, and then we'll take that back and discuss it within our own group, then move forward with a draft. And in this draft, what we're trying to get through to the customers is the possibilities and what the end possible product could look like, and then to get information back from them on improvements we could make. And then we have that refinement meeting, and then we produce the final output for them. And then the steps usually follow a data cleansing, then we make it spatial, integrate with other spatial data sets, teach and empower the end users and subject matter experts, and be there to support in the future when questions arise.
Reid, it looks like you keep accidentally hitting your mute button there when you switch the slide. There you go.
Sorry about that. I must be pressing the space bar, which is muting me. First, we began by data cleansing. So to cleanse this data, it was coming from 7 different districts, and they were all coming in different formats, different fields. So the first thing, we sat down with them and said, we need the data set up in this way. And I think that is a very important thing to communicate, not only their needs to us, but our needs from them. So once we established the needs of both groups, we had our expectations set, and then we finally got a standardized data set. So moving forward, after we got our data set, we then made it spatial. And these are 2 images that I'll talk more about in the next slide. This first one here is showing the broken route network at each milepost. This is allowing us to bring in the Adopt a Highway sponsorship data and attach it to each segment. So to integrate it with other spatial data sets, we needed to use our ATIS route network from ADOT, which encompasses all of the routes within the state. And here we're just concerned with ADOT-owned roadways. So we first began by collecting all those ADOT-owned roads, and then we split them at each milepost. After splitting them, we were given our segmentation. With this segmentation, we performed a reverse geocode, which allowed us to gain our from and to mileposting. With all this, we now had our final segmentation of the routes. Now all we needed to do was get in the attribute information from the Adopt a Highways datasets. To do this, we utilized a common field or a unique ID between the 2 fields. And to gain this in the Adopt a Highway dataset, we first geocoded it to get the route and milepost. And then we split them at the milepost for the ones that were longer than a mile. And then we had a unique ID field for all the segments within the state. In doing so, we were able to join these attribute data to the route network and get our final data set. After that, we reached out to the end users, the districts, and we trained them on how to do this in the future and how to interact with the database appropriately. And this helps to keep the data owners managing the data, moving us into a position of support instead of a position of managing data that we are not the subject matter experts of. And here we ended up with our final result. Now this is not the final result of the permitting system, just the data set itself. So this is what we gave to the districts after we thought we were done with our final data set, and this allowed them to go in and see available segments, and unavailable segments. And this was a way to validate the data set that we put together for them so that we knew that everything had been included that they were hoping to see in it. And I'll pass it to Robert here to show the second example.
Thank you, Reid. I appreciate it. Our second example is about pavement improvement visualization. In the state, to maintain the pavement, they do a number of things at ADOT. There's construction projects that commonly do what's called a mill and fill, where they mill up from a ½ inch of road to 6, 8 inches of road, take it off site to a plant and regurgitate it and put it back down as fresh roadway. There's corrective maintenance items that they do, like slurry seal, chip seal, stuff like that. And then preventive maintenance, fog coat and crack sealing and microsurface stuff. Each of these is managed by different financial means. Construction projects are done in construction projects by actual plans at the state level and done through the state engineer's office and everything like that. Corrective measures are more at the district level. ADOT has 7 districts, and each district has so much money to spend and spends it where it best sees fit. And the preventive maintenance is done almost at the maintenance level. These are 47 maintenance units located around the state of Arizona. The problem was there was not a lot of communication on knowing, okay, there's a project going on, a mill and fill here, but we just put down a crack sealing in that same area a year ago. People weren't sure who was doing what, where, and how to maximize the condition of the road to keep it in a good quality road. Now, how do we track this stuff? Well, ADOT, with our group specifically, has a roadway quality van run the state highway system every year, as well as the national highway and additional roadways, that collects the quality of the pavement of the road, the rutting, the cracking. All that information is collected every mile. We also have construction plans telling us when new construction's going on, where they're putting mill and fill projects down, and where corrective and preventive maintenance costs are being tracked in what's called a PACOS financial system. Go ahead, Reid, to the next slide. So what does this mean? Multiple data sets, tabular data sets, geospatial data sets, even CSV files in some cases, all being brought together to somehow figure out how to make useful information visually attractive to the director of ADOT, to the state engineer, and especially to the districts and maintenance units, so they can see what work, what needs to be done. So what we did was we brought all this information together, and Reid was especially important in doing this because it was his knowledge and abilities that brought this together for us. We brought in the pavement condition for the last 3 years. Each year the pavement is done and it's run. We brought in all the construction projects. So now we have a layer on the geospatial layer where the construction projects were. They were on I-17 from milepost 250 to 265, for example. We knew they put down a mill and fill in that particular area in this particular year. Through the PACOS information, we found out where the slurry seals were, where the crack sealing was going on, and everything like this. And we made layers for it. Go ahead to the next screen, Reid. So this is a static shot of what we got. Reid's pulling up the actual map that he put together, and this allows everybody, public included, if you have the link, to go look at what was done within the work. And what's nice about this is the analysis that's now available to all the engineers and to the maintenance people. With a limited amount of funds these days, people aren't traveling on the roads as much as they used to. So ADOT's income through gas taxes has gone down. Unfortunately, that also means our construction budget has gone down. So we need to prioritize and understand where best to spend our money to keep good pavement good and hopefully get fair pavement up to good. This allows the maintenance units and the engineers to go in and see what's the quality of the pavement year after year. They can see how fast it's potentially deteriorating. They can see when a project is going to be done, and they can see when a mill and fill was done. I'll let Reid go ahead and explain a few things about it, because this was his project that he made for me. Go ahead, Reid. Make sure you're not muted.
Yes, so this dashboard here was important for the districts to go in and see where they could allocate budget to making good pavement, keeping it good, I should say, keeping good pavement good. So they can go in here, zoom to an area, pavement conditions appear in green if they are good, orange if they are bad. And then we have our SLI pavement projects here. So we can see here, there's a section on 74 that has good pavement that has not had a project done. So it would be a good area to allocate funds to keep the good pavement good. So this allows multiple data sets from different groups to be brought together geospatially to have geospatial analysis done on them. So really, to sum it all up here, we feel as though the biggest thing as GIS analysts, professionals, that it is important to be empowered as a worker. And you need to always be looking to increase current processes through efficiency and user experience. So anytime that you see an efficiency problem or a user experience problem, don't feel bad to speak up to your group and to talk with them and to talk with your colleagues about possible solutions that could be done. And in both of these cases, that is exactly what we had done. Reached out to these other groups, telling them how we could support them in the future. And it resulted in increased user experience and an increased efficiency as well. So in the Adopt a Highway, it allows the districts to go in and edit the data themselves and to visualize it themselves without us being a part of the process. And in the pavement improvement visualization, it allows district engineers to better use limited funds and maximize return on investments by keeping good pavement good within our state.
So what else have we done? We've been working with the bridge team with the National Bridge Inventory. As Reid explained, we've been working with permits. The Adopt a Highway was kind of the kickoff for permits. ADOT also does a lot of other stuff on overweight, over height permits. And this is just the tip of the iceberg, working with the permit section on turning their data from tabular and everything to a geospatial environment that not only can they work with in a more cleaner environment, but as all of us know, it plays well with others. That's the key, is data, geospatially accurate data plays well with others. We're, as I said, working with the pavement team, our 5-year plan. I don't know if many of you have heard, but there's works in the way working with the state legislature to open up the ADOT right-of-way to share fiber access so we can get fiber to the entire state. That's in works, and we're working with them on that. Traffic studies with junctions and accidents and things like that. Another group was feature inventory. They're the ones that have the signs, the gullies, the bridges, as far as over, drainage bridges and stuff like that. They have guardrail, end treatments, all the stuff that you find alongside of the road, working with them to geospatially get their data as accurate as we can. Maintenance management systems we work with because they're the owners of the district and maintenance boundaries. They are the ones that tell us where each of the districts and boundaries cutoffs so that we can relay that information and they know where their boundaries exist. And then we're also working with people in the Metro Phoenix area that are doing a lot of cleanup with the ADOT right-of-way around traffic interchanges and ownerships and easements and temporary construction easements and stuff like that, where they can now accurately track the right-of-way and where there's a transition from state ownership to city or county ownership to know how much roadway ADOT has. Go ahead, Reid.
In the end result of all this work, groups are able to answer new and old questions with data sets that had previously not interacted well with each other. This leads to a more informed, data-driven decision-making agency, and we are happy to continue doing this work, and it's exciting and fun. Thank you all.
Go ahead to the next screen. And this is our contact information, both our ADOT email and telephone numbers. If you see, you got Reid there standing on the north rim with his mountain bike, having gotten to the top there. For me, I'm not going to tell you where I'm standing. It's a trivia question. See if you know where I'm at. It's Arizona musical history. You tell me where I'm standing. So it's up to you. We hope you appreciated today's demonstration and kind of a talk on a little bit how we got into these other groups. Unfortunately, there's a lot of old school mentality that exists in a lot of government agencies, whether it's state, city, or county, and it can be a job getting your foot in the door in those. Fortunately, with my years on the road and traveling over the state, it's given me a perspective to get my foot in the door personally with a lot of these teams because they knew my work. And when they saw what we could do with my work, how about we do this with your work? So it turned into a win-win situation for both of us by getting these towers of excellence to crumble down, let us actually finally have access to the data and share it with everybody. So do we have any questions?
We do, Robert, we do. The first one up is, I think this one might be for Reid, but maybe for both of you. What are the unknown segments and why are they unknown? This refers to the first example, the Adopt a Highway.
Yeah, so in the Adopt a Highway, those are unknown segments because the Adopt a Highway team never specified if they were unavailable. So some sections within the state are unavailable because they are deemed too dangerous for volunteers to go clean up the area. And so they weren't filled in with unavailable and they weren't filled in with sponsored or volunteered. So we were unclear. So that's why in that visualization, we were reaching back out to them to show them the data set and to try and fill in some gaps.
Okay, great. Next question. Do you have a maintenance plan, so to speak, where you check in with the districts to see how they are keeping up with the plans and standards?
On that, I would say what we will be doing is getting the reports from PACOS on an annual basis, which will show us where the funds were spent and how they were spent along the roadway each year. The same with the FUGRO data. In essence, all of the data that we collect, even though some of it could be updated even on a monthly, if not quarterly basis, it's more than likely going to be an annual map just because of the road conditions collected once annually. The construction plans and everything that go through are usually collected and prioritized from July, August through February, March range, where they all get entered into the system and everything like that. So keeping everybody informed will be done, but it'll be on an annual basis.
Okay, great. And a question that's been asked a lot is, are these, the maps that you presented here online, are they accessible to the public or is they internal only?
Go ahead, Reid.
At this time, the Adopt a Highway data set is not available for the public, but the SLI is.
The SLI, by the way, is the pavement data. That's what they call the maintenance units and districts work, the slurry seals, the fog coats, stuff like that. And I even had to ask what it stands for. It stands for a state line item. In the state budget, there's actually a line item for these funds specifically to take care of the road. So they refer to it as a SLI project. And those and that map is accessible to anybody.
Great. Can you maybe give us that link and we'll get it into the chat? Can maybe put it into our chat here and we'll get it to the attendees in their chat if you have it. Link
Yeah,
it.
Reid.
Yeah, I'll drop it in the chat.
Great, thanks. Okay, next question. Oh, this is a good one. Did you encounter teams or divisions who were reluctant to integrate their data with a more integrated system? And if so, how did you handle this?
We've actually got that going on now. It's taken a little while. The biggest thing, and I point blankly, I'll pat myself on the back. I've built a relationship having my time with ADOT and the photo log. And fortunately, the photo log is well received around ADOT. And that is what allows me to crack the door, basically, get my foot in the door and start talking to people and explain to them what GIS is capable of. For instance, in talking to the pavement team, their pavement was a standalone database all by itself. Great data, awesome data, everything you wanted to know about pavement. But when we showed them what you can do if you make it geospatial and you share it with everything, now how about we take and do an analysis where you can do something such as, let's compare where speeds are posted 45 or greater at elevations of, let's say, 1,500 feet or greater with a turn radius of 10% or tighter on an asphalt condition of 1, 2, 3. What does the pavement do over the last 5 years? Does it deteriorate? And if so, how much, as opposed to something else? So now you can add all these factors into it, just instead of just looking at it and saying, yes, my pavement's deteriorating here, but we don't know why. It's because you don't have additional data to support yourself. When you make the data geospatial and you share it with everybody, now you can start doing an analysis and comparison. Why is this same exact asphalt in this location good, but here it is 20 miles away and it's deteriorating 3 times faster? Why is that? GIS gives you the tools to potentially find that out. And when I tell them this and give them examples of this with other teams, pretty much we still have the naysayers. I won't lie about that. But for the most part, most people get on board and come willingly and want to see what it can do for them.
Great. There are a couple more questions that we're not going to have time to get to, but for those of you attendees, we're going to see if we can get those answered, get those answers typed in there and get them to you. Otherwise, you can try to connect with our presenters, Robert and Reid, through the community attendees list or via their emails that we've put into the chat for you. Thank you, Robert and Reid. That was really a great presentation, a lot of great information, a lot of questions here. So we're going to get started on our next presentation. Without further ado, we're right on track. And okay, for those of you who've been to an AZDOT conference before, you probably know Bo Guo. He's a very popular presenter at our AZDOT events, and we're thrilled to have him again virtually. Hopefully we'll get to see each other all in person next year. And with Bo today is Shujing Li. So those of you that don't know Bo, by the way, he is president of GIS Research, Inc. He's over 25 years of experience in GIS and IT in the NG 911 and GIST, that's transportation space. His recent passion is in the research and development of collaborative and distributed GIS maintenance platform for government agencies. And Shujing Li is his colleague. She is the lead developer at GIS Research, and she's going to show you some great stuff that she's been working on as well. So I'm going to turn it over to you, Bo.
Thank you, Jamie. Share my screen. Must be this guy. Jesus. I got confused here. Okay, hold on. I thought I had this slide open.
Yeah, we're seeing your Zoom browser window there.
Oh yeah, I think it's right over here. Must be, yeah. I just
There
need
you
to
go.
put on the presentation mode. Okay. Whoops.
Looks great.
Sorry about that. And before we look into the future, I think it's quite relevant. Let's first walk down the memory lane of the last 40 years on the technology adoption and the events that are relevant to the mostly vector-based GIS management. And I think in the early 80s, and GIS workstation was the norm among the early adopters. And the backdrop of that was the PC revolution, which led to the wide government adoption of GIS. And now let's look into the following decade and a half. And the World Wide Web took the world by storm, of course. And later, the smartphone essentially repeated the same feat. And during this 15 years, 20, 15 years time, I thought there was some important geospatial development, one of which is the spatial DB technology. And the other is GIS server technology. And the third is online WebGIS, approximately in this sequence, in this order. Why these are important? Because spatial database essentially invites GIS into the enterprise database system. So GIS no longer alone by itself as just creating pretty maps hanging on the wall. It's actually integrated with the infrastructure, the broader IT infrastructure. Then coming to more recent years, the past 10 years, I think infrastructure-wise is mostly cloud-based computing and artificial intelligence that we all are aware of. And there are some important, during this 40 years, I think it's punctuated by some of the important GIS technology development. I would like to name a few. First, I think in 1982, ArcInfo was first commercially available, okay? And then second, I would say the Oracle Spatial and later ArcSDE, as we know today, at the time just spatial database engine, is around 95. And again, that importance is bringing GIS into the SQL family. And one of my favorite is MapQuest. I vividly remember 1996 when I was working for Maricopa County DOT and or using the browser, we're able to plan our trips. So that was actually the start of beginning of the end of the triptych. I think, Triple A's triptych, all those maps that Shay mentioned in the opening days of our conference. So it was quite interesting at the moment, is an eye-opener that maps can be delivered and planned trips, routing can be delivered on a web browser. And more recently, I think what's important is what I think is OpenStreetMap. OpenStreetMap is more than just providing yet another free base map. It is, in fact, it's the collaboration nature, the crowdsourced map that's so inspiring. think about it. Each and every day, there's tens and thousands of people around the world. They are contributing to the one and only one centralized database as our digital map infrastructure for free. And that's a collaboration. And people participating in this has little or no training needed. They're participating in this process, making the things essentially can drive by itself by providing this platform. I think it's very important. So how all this relate to what we talk about today in the statewide GIS integration? Well, I think there's one more traditional one. It's called state-led ETL. Okay. By the way, ETL stands for extract, translate, and load. By that, you know we're duplicating data. Data is not, essentially we have separate data, you process it, you send over, right? So ETL is in that sense. And this started pretty much as more and more government agencies started adopting, the GIS adoption. There's a need to aggregate them together on a statewide or region-wide level. And the technology pretty much using the late 80s and early 90s technology. We don't really using anything, you don't even need the internet technology or server technology. And more recent variant, I would say, is called self-service ETL. And still ETL, it has its own issues with it, but self-service ETL, it leverages the server technology and need the infrastructure of the internet to service it. And I personally is looking into the future, and it's actually happening, I think, is the online collaborative approach. And this leads to my next. So let's first look at a state-led ETL-based integration. So this is one of the local agencies. They have their data set. They just throw over the wall and they're done. And the state had to do a field mapping, QA, QC, map stitching, and put them into a statewide GIS. And oftentimes, not always, state will create a local data set, say, hey, these are the ones we cleaned up and all stitched well with the rest of the world in the state. And here are the report of QQC, and state throw over back to the local agency. And it is always questionable if those will be ingested into the local agency, which that potentially this actually happens and the same error will come back again for the next cycle. So that's what the state-led ETL is. So now look at the variant is again the same local agency. They're creating their own data set and they try to throw that over to the state, but this wall is very, very high. And this wall is also has intelligence in it. When you throw against the wall, it produces error report and bounce right back to say, hey, these are errors you have, go fix it. The wall you can only penetrate this wall until you don't have any error. So the state will getting a mostly QQC data. However, still need to do stitching. Stitching is by no means is easy. And if you have multiple polygons, that's especially tough because polygons are objects. The slivers, the crevices would happen. But again, it's much cleaner. So the future, I'm using this as really broad architecture, well, I wouldn't say architecture workflow, is all the agencies, they're working together on the same centralized platform, and then which result into a seamless statewide GIS and controlled by the rules set by the state that's relevant to the state as entity and also to the local agencies as entities. okay? And the result, the data result being shared by everyone. This is kind of like OpenStreetMap, except we have small number of participant being agency rather than individual. So let's take a look at the issues and resolution from the state perspective. So what's wrong earlier I mentioned about this ETL, state-led ETL, this kind of ETL approach, you always have the data currency and redundancy issues because ETL by nature, you're making a copy of it and translate it and throw over the wall, right? So there's always the redundancy and the currency. The moment you have this copy done, most likely its original source has moved on, right? There's also an ambiguity in authoritative sources. Which is more authoritative? Do you think the state, the pieced together one is more authoritative than the local one, which contributed to the original data? So that's ambiguity. It's hard to reconcile. And then state does the heavy lifting. Think about the cases, schema mapping, stitching, QQC. That's a lot of work. And again, the source data may not have improved, so we have to keep doing it, like Groundhog's Day for each and every season. We might have to do it on a quarterly basis. We have to go through that on a quarterly basis, yeah. And lots of cat herding, which is very hard, very tough. And there's the self-service ETL essentially improved some of the aspects of that. Of course, with the first authoritativeness of data and redundancy concurrency of data, currency of data that hasn't been changed. However, only stitching is needed at the state level. And I think the data issues is improved, self-improved, and possibly, hopefully eliminated if the local agency stick to its original plan of doing it. Yeah, the process doing it. Less cat herding. The online hub is very promising. As you can see, there will be little cat herding and little GIS work is involved. So this is a potential architecture, which I name it as the hub and spoke collaborative federation model. It accommodates different levels, different types of agencies. Some agencies who does not have any GIS or enough GIS. So the state might delegate state might do it. They can use the hub GIS UI to do it, or they can use their internal enterprise GIS database, which is synchronized or replicated, two-way sync with the hub database. So that hub will always have the most authoritative data statewide. Yeah, so this is kind of a high level architecture. Well, we are going to do a collaborative boundary editing prototype model. And my colleague, Shujing, who is the lead developer for GISTIC, by the way, she's behind almost all GISTIC software products on front end. And I'd like to take a moment and think about if you are the user of a collaborative boundary editing platform, a product, what would you like to have? Think about multiple people, multiple agencies need to collaborate on that. Think for a moment, what would you like to have? I think we need to define the editor privileges. If you are in agency A, you're only confined to work in the agency A's data. You don't have any business doing agency B's data, right? So that's privilege need to be there. Then because boundary editing in particular, you might editing your own polygon, but neighbor might be impacted. So there needs to be notification so that the collaboration can ensue. And we need topological based editing. And if you ever worked on polygons, which is typically, oftentimes, even within your own agency, you might not use a topological editing. The end result, you might have slivers and crevices. So topological based editing is a must in the collaborative setting. I think also generally speaking, we need to do defensive data maintenance and real-time QC capability so that the bad data will cannot even get into your system. Because at this moment, like many of our consulting work with other state agency, other state or local agencies, we end up just dealing with massive, sometimes very significant data issues simply because the entry point hasn't been controlled. And there's a lack of real-time, at-a-time QA/QC capability. So I am a big proponent of defensive data maintenance. And lastly, but not least, need to be simple and performant web UI. Because when we're talking about collaborative editing, it's all web-based. We cannot use desktop. And desktop, yeah, typically, so we need to make it really easy and simple to use. So with that, I'm going to invite my colleague Shujing to take over and to give us a demo. And during the process, during her demo, please look into all these 5 kind of things, see how well we've been hitting it. Okay, I'm handing this over. Thank you.
Thank you both, and thank you, Jamie. Let me share the screen. Okay, this is the GIS app. We are logging in as a simulated Santa Cruz County provider. This is a dashboard page, which lists all the layers user has loaded. So we can see Santa Cruz currently only has collaborative layer. Let's go to collaborative layers to view the contents. So we have the provisioning boundaries data here. There are 2 views we can choose from. Currently, we are viewing the data in the map. If we switch to the tabular view here, we can also see the attributes and some logical errors in this data. So we hover over this icon here, and the red area flashing on the map, it's the topological errors that's in this area. You see it has some self-overlaps and gaps existing. This red area in the table indicates there is something wrong with the attributes. So in this case, if we hover over the header, you can see this column, this field is required for this data. That's why it shows error. Okay, you also notice there are some data dimmed out. This is because those data don't belong to the logging agency. User can only edit the data that belongs to his or her agency. So in this case, we can edit the Santa Cruz data here. So let's say this will expire in 2022. So this is the attribute editing. To edit the geometry of this area, let's go to the map view. Okay, so if you right click on the other county's data, you can see the editing is disabled. So right click on Santa Cruz and start editing. We are entering the geometry editing mode. So on entering this geometry editing mode, the topological errors related to this area are computed. The red area indicates there are overlaps. The green area indicates there are gaps. You can see from here have about 20 overlaps and some gaps and crevices. So clicking on this record, you can take a closer look to the gap. If we zoom in, you can see this is the overlaps between these two counties. So let's select all of the overlaps and resolve them. So that resolving it means we fill the gaps and remove those overlaps so that we can have a cleaner boundary for users to edit. And if you commit those fix, you can see those agencies, neighboring agencies, which whose data, whose boundary that those changes has been made, they are notified. Okay. So now we can start to edit the boundaries here. You see, if I edit the vertex, the topology relationship between the Santa Cruz and the neighboring boundary, it's maintained. It remains the same. Okay, so this is the
Great. Yeah, I think what Shujing has shown, this prototype still under development, but it showed potential of real-time checking. So when you resolve those errors, and immediately it shows the result being removed. The same thing goes if we make edit to any of the attributes. If the new attribute is entered or violates certain rules, it will complain and will not allow you to save or commit. Yeah. So, and we also earlier we had the crevice. Essentially, the topological errors have three types of them. One is overlap sliver. The other is gap sliver. So right over here, yeah, gap slivers. And then third is the crevices. And crevices essentially open areas. We use topological geometry calculation to identify them. Then so that by resolve, essentially, we'll either trim or remove the overlap portion of it and attribute the overlap sliver to one of the two, maybe three bounding areas, right? And then this is how we resolve this. And it is still in a testing mode. Sometimes things does not work quite well. We are testing with different precision and testing different combination of that. But we think, to me, that polygon editing needs to be topological. Otherwise, we just cannot win. There's just so many gaps and minor gaps you don't see. But again, GIS is more than just with visual. It is actually, when we are using it for analysis purposes, they need to be precise. It's no longer, they looks like they are neighbors. It looks like they are all perfectly fine. Of course, a 10,000 meters high it is, but if you zoom close in, they are not, right? So these are the issues. I think we just use collaborative boundary editing as an entry point to demonstrate this potential. I think that's it. We leave 5 minutes for any questions for Shujing or myself.
Great, Bo. This is really cool stuff you're showing. Really impressive. Yeah, there are a couple questions, so let's get to it. First one is it possible to have confidential data in a hub that can only be accessed by approved users?
Yes. In fact, I don't know if any of you have read my most recent article on LinkedIn talking about my second installment on statewide GIS. Is called the invisible lasso. In order to have this invisible kind of lasso to herd the cats, there are multiple criteria, multiple things, a function requirement needs to met. One of which is security. And another is the mapping, the persistent schema mapping. Security essentially saying, hey, we need to support local attributes, right? But this local attributes may be local only. This attributes need to manage by local, but also there's a copy on the hub. But this copy on the hub is totally encrypted so that only local have the key to access that. So that's one critical thing, yeah, in terms of the synchronization and what have you. And we're working on this capability. And so again, local should be able to do, in addition to meet their internal needs, they need to have their internal columns and attributes and rules that need to be supported. Yeah.
Great. Okay, next question. With the integration of ETL, where do you see this platform, say, in 1 year down the road? Great question.
Could you repeat that question? Was the
Sure, they're asking about with, now they have the integration of ETL, where are you seeing this platform go in like about a year from now?
Okay. This GIF 2.0, the collaborative nature, we have just started developing at this moment. And a year down the road, we hope to find a willing state agency to do pilot, to do trial. And that's our goal. And we should have this platform, all the features that we can think of pretty much built out by the end of the year, if not later part of next month. But our next thing is education and working with people, finding a state agency doing a pilot. That's what we think. And we think this has great potential.
Yeah, I think you're probably right. We have one more question here. Who fixes these errors in that data?
Who fixes?
Yeah, who fixes the errors that in that data? I assume they're talking about the ones they're looking at there on the screen.
Yeah, and I think typically, let's say if you're Santa Cruz, you're only confined to your own data, but the boundary is part of you and part of others, right? There's you and others all involved. So go ahead and do the modification. The other party will be notified. Then we, in the case, we need to have a confirmation process. Any boundary polygons being modified by other party need to flag in the state of unresolved state or whatever state we still yet to come up with a term for it. Then only both party have a signing process saying, okay, this is it, we like it. Then we have that secure being confirmed. And by the way, one other features of this, all this needs to be transactional, meaning that you can go back to knowing who did at when, including the confirmation process.
Okay, great. Well, that's all the questions we have. If anybody has additional questions, you can reach out to Bo and or Shujing and through their email, or if you if you and Shujing have made yourself visible in the attendee list here, they can also message you through the community platform here. But email might be better, I'm thinking. Or they can probably find you on LinkedIn and all your great articles.
Thank you.
So
Will
I
do
am
that.
going to, with that, I'm going to thank our presenters and thank our attendees for coming. Please remember to complete the session survey. It's on the button on the right side of the screen there. Your feedback is real valuable. It also helps our presenters, and it helps us also plan for next year. A recording of this session will be available in about an hour and 15 minutes after this session is completed. And again, to connect with the speakers, you can send them a message also on the community attendees section here. Thank you again, and thank you again to our presenters. It's a great job. This is a great session.